We present stucco, soft tracking using contacts for cluttered objects to perform blind object retrieval. This involves grasping a target object of known shape but unknown pose without visual sensing. When retrieving an object from cluttered spaces, such as cupboards or refrigerators, we often have limited or no visual sensing. In these scenarios, contact feedback is necessary to estimate the object poses. The fact that objects are movable while their shapes and numbers are unknown makes the association of contacts to objects extremely difficult. Prior work on multi-target tracking include methods that propagate these association hypotheses, but the number of hypotheses grows combinatorially with the number of contacts, and pruning them is difficult because ambiguities may only be resolved with data much later. As a whole, most prior work requires receiving long-range information at high frequencies to be effective. Our key insight is that we can efficiently propagate a belief over contact points without explicit associations. We represent the belief with a particle filter, where the prediction and update steps are based on the basic assumptions that points closer together are more likely to be of the same object, and that contact only occurs on the surface of the robot. Please see the paper for more details. Our method is agnostic to how contact points are extracted from each contact. We use the contact particle filter based on estimated external wrenches, but on the real robot, we show how to augment it with more advanced sensing. Next, we show our method in comparison to some baselines using clustering methods. Our method is on the top left. The same action sequence is run for all methods. Propagated contact points are labeled as crosses with their color indicating their segmented object. The best cracker box pose estimate is also plotted in blue. Note that although our initial associations were wrong, we were able to revise it after physically exploring the gap between the two objects, because those points are inconsistent. The baselines were not able to revise previously wrong associations since they only keep a single best estimate of the contact points. The Gaussian mixture probability hypothesis density filter propagates its components using linear Gaussian dynamics that are state and control independent. It's not able to exploit the locality of contact, with its global updates leading to forgetting of previous contacts. Finally, we demonstrate our method on a real robot, with an overlay on the top right indicating our tracked contact points. We remind the viewers that the robot is blindly rummaging and has no access to visual perception. The gripper is equipped with two soft bubble sensors, which have a depth camera inside that enables us to measure the imprint with respect to an undeformed bubble. This is shown on the top left. We average the pixels that exceed a threshold, then project and transform that point to a world frame contact point. Future work will investigate how to better exploit the rich information provided by a contact patch. For contact isolation, we essentially have three sensors. The contact particle filter is only used if neither bubble detects a contact, useful for detecting contact on the front and side not covered by the bubbles. See the paper for how we deal with potentially multiple contact points per step. Over 5 runs on the robot, stucco achieved 100% grasp success, while none of the baselines achieved more than one successful trial.